So with that being said, then what is a presumptive test? Presumptive test indicates that the test is... Sorry, what did you say, Mareka? Not 100%, but can't you say it's not 100%? Because that actually makes it sound really bad, right?
It's highly accurate, but not 100%.
Good. Highly likely, highly accurate, but not 100%, right? So the idea here is that a presumptive test will get us a pretty good answer. Highly accurate, highly likely, right? But it does give us an allowance that it's not 100%. Okay, and we'll talk about why and how we use presumptive tests a little bit later. So we're going to talk about 3 presumptive tests today. Most non-Enterobactericiae, or enterics, are what for oxidase? Positive. Good, so we can use the oxidase test to differentiate between the enteric and the non-enteric, or the Enterobactericiae versus the non-Enterobactericiae. The non-enterics are positive. Streptococci can be differentiated from staphylococci because they're negative for what test?
Catalase.
This is the catalase. Notice, by the way, streptococci, staphylococci. What am I describing here? Shapes, yeah? So we're talking about bacteria that look like this versus bacteria that look like that. Not the genus. We're not talking streptococcus, the genus, staphylococcus, the genus. All bacteria that are circular and line up in chains versus all bacteria that are circular and clump. Right? And again, it's a presumptive test, so by that really we mean most, right? So notice that difference, yeah? To test for catalase, what reagent are we going to use? Good, so we've done the catalase test before. It's nice and simple. Amongst the staphylococci, there's one specific bacterium, Staphylococcus aureus, that is always troublesome for us, right? Many tests have been used to identify it. What specific characteristic are we going to look for in this case? The what? Coagulase. Good. One word in this case would have sufficed, this one, right? But this enzyme called coagulase, yeah? Which separates it from the other non-pathogenic bacteria. Questions? All right, so lab 17 is all about this thing here, right? The concept. Why is that in black? This is our concept. We want to talk about this presumptive identification, right? So we want to talk about what a presumptive ID is and how do we use a presumptive ID to identify bacteria, okay? Because they have their uses, but they also have their negatives. Pros and cons to everything, always, right? Now, we talked earlier about a way to identify bacteria. What do we use to identify bacteria? How do we identify? Pardon? Phenotypes, right? Good. So do you guys remember how we looked at phenotypes of bacteria? What we did exactly? Many ways to do this. Sure, staining is one, right? Staining gives you limited information, by the way. Gram-positive, gram-negative. Some kind rod, some kind coccus, right? So it gives you better, but limited, right? How do we get that, the nitty-gritty? We talked about that as well. Fingerprinting, right? Our biochemical fingerprint, right? Remember all those different biochemical tests, right? That's the traditional way of identifying microbes, right? Now, it turns out that doing that is actually difficult. It's time-consuming, right? Minimum, how long before we get a biochemical test back? How long?
30 minutes.
Not 30 minutes. Oh, remember our biochemical test we did in Lab 11? I remember we inoculate, right? And then every time we inoculate, do we get back the results right away? A day, right? Always requires incubation, always takes minimum a day to get those results, right? So it takes you at least a day, and sometimes, and we'll see this, Sometimes the test results lead you to another set of test results, which then can lead you to another test results, which then can make your identification scheme take up to maybe even a week, depending on what you're doing, what you're trying to find. And even then, two very similar bacteria may be hard to differentiate based on biochemical tests alone, right? So that's difficult. Sometimes in a clinical setting, you don't need that level of understanding. Sometimes all you need to know is, hey, is it this or this? That's really all I care about. I don't really care exactly the details. All I need to know is it A or is it B? Once you know that, then you can carry on with the analysis, with the diagnosis, all right? Prescribe the correct medicines. So what presumptive IDs do is they allow us to get right at it, right? It's often a single rapid test. Oftentimes, results come in less than a few minutes, right? In fact, some of the results that tests we're going to see today, the results will come in like almost instantly. So almost instantly, you know what your presumptive ID is, right? And the ID itself is highly accurate, but not 100%, right? So you have this pretty good idea, right? Enough to move forward, right? And maybe the lab test will confirm it later, right? But you have enough. Now, there are limitations to presumptive ID, right? First of all, we have to understand that it is not 100%. When we say most staphylococci are this, or most enterics do that, right? We do have to allow the fact that there might be some other issues, right? So how do we get around that problem? How do we get around, remember my goal, 100% accuracy. How do we get around the issue of using tests that are not going to tell you 100% proof?
Do tests that can't give you 100% proof of what it's not.
You can't keep testing because you're going to get the same result, right? Not 100% every single time will give you not 100%, right?
So you use other tests to compare it?
Sure, not just other tests, right? But you want to take other information as well, right? So you have all this information that then allows you to come up with your presumptive ID. And what does it mean, by the way, to presume something? How does that differ from assume? Two words we often use quite interchangeably.
Presume before you know. Presume before you assume.
Oh, no. If anything, you could say it the opposite way.
And assume.
What does it mean to presume or to assume?
Presume is just an estimate, and assume is a definite. Does that make sense? Yeah.
Right, so
Like, oh, no, I am
an assumption is a guess,
Okay.
right? A presumption is an educated guess, if you will, right?
Oh.
So let's say I see Denise, right? And in my stereotypical bias, I see her as a criminal. She just got the look of a criminal to me, right? She just looks like one. That's an assumption, because I'm using bias. I'm not really basing it on anything, right? Now let's say I see her, she's running out of a house, she's got a stereo in one arm, a laptop in the other, looking around frantically, alarms are going off, right? And then I say, oh, she's got the look of a criminal, right? That's different now. That's a presumption, because I'm using the other information to come at my identification. I could be wrong still. That could have been her house. It could have been a fire alarm. She's just grabbing her valuables out, right? But based on my information that I have, I made my presumptive identification. Same with this kind of stuff. You would never use one of these tests as your only test. You would never say, I wonder what my bacterium is. Let's just do a catalase test. It doesn't work like that, right? But you can say, well, I know this, and this. I'm pretty sure it's going to be somewhere around here. My presumptive test will now let me determine this or that. Does that make sense? So that's a very important thing about the presumptive ID. Fast, super easy. Really allows you to get at the heart of the problem in a quick way, right? But you can't just do it. You need some information, right? So with the catalase test, we use the catalase test to presumptively differentiate staphylococci from streptococci. All right, and there's something that's really not said in there. These are gram-positive, right? So we have gram-positive staphylococci, clusters, versus gram-positive streptococci, chains. All right? The catalase test allows us to differentiate that. Now, prior to doing the catalase test, what must I know?
What it breaks down.
No?
The shape.
How they
The
are
shape,
differentiated?
right? And based on what's written up there,
And the site.
no. I need to know the shape and
Arrangement.
so what I'm looking at is I have a gram-positive coccus. I know that. Right? It looks sort of staffy, looks sort of streppy under the microscope. Right? I also know based on the signs and symptoms, it's definitely going to be one of those two. Some sort of strep, some sort of staph. Treatment is going to be different for the two. I just need to know which one it is so I can start treatment right away. So we do a catalase test. Right? Which one is positive?
Staphylococci.
Good. So staphylococci is going to be positive for catalase. Right? And remember, to do the catalase test, it's going to be simple. As many drops of hydrogen peroxide as you want, right? On each slide, you can do 2, you can do 4, whatever you want. On the cart, there's a plate that says gram-positive cocci, A, B, C, and D, right? Take a loop, mix it in. What does a positive look like? Bubbles, right? So we want to see bubbles. So positive means positive. Bubbles means positive. So if you see bubbles, what's your assessment? It's a staphylococci, right? And on there we have at least one staph, at least one strep. Cool? Out of the staph, one of them is Staph aureus. Okay? How do I determine which one is Staph aureus? The coagulase test. Good. So out of all the catalase positive staphylococci, you'd follow that up with a coagulase test, right? And the coagulase test helps you test for potentially pathogenic Staph aureus, separate that out from the other non-pathogenic staphylococci, right? And once again, when would I use the coagulase test? What would I need to know? It's definitely, we need to know it's a gram-positive staphylococcus. What else? We'd like to see it being catalase positive. Right? So we have all this information. And then you have a suspicion. Oh, based on all the information that I've gathered, I suspect this might be Staph aureus. Coagulase test will help you determine that. Make sense? Good. Coagulase test, also relatively simple. Take a slide, nice and clean for this one. A drop of rabbit plasma. All right, so we have rabbit plasma on the cart. I'm going to move it to the front. There's a dropper. Put a drop on there. All right, not too big. Take a loop and then mix it in there. All right, and what you want to see is clumping. All right, give it a nice stir. Okay, and what you're going to see is this. Do it on the black bench. It'll be easier to see. Okay, so not on the white paper towel, on the black bench. And then when you first put your plasma on there, it's going to be like this cloudy solution. Okay, mix it, takes about a minute or two, and then it'll start to clump. That's what a positive is. Okay, and the clumping is going to look like the cloudy solution will all of a sudden clear up. It'll look like water with specks of sand in it. Large specks of sand. And you'll see it when you do it, okay? When you're doing these tests, by the way, don't just do it. Wait for your group, right? Because these tests are quick. Make sure that everyone gets to see what it looks like, right? So you say, okay, I'm ready for the catalase test now. Everyone kind of gather around and you just watch it, okay? Make sure you sterilize your loops very well. Any questions? So out of those 4 gram-positive cocci that are on there, one of them is Staph aureus. And at least 2 are Staphylococcus. So try to find out which ones they are. Cool? For our gram-negative rods, right, and these are for gram-negative rods, we use our oxidative test, right? A presumptive test to differentiate our non-enteric bacteria from our enteric bacteria. Okay? Out of the 2, which one is oxidase positive? Or non-enteric. So this one confuses because it's the opposite. Non-enteric is positive. So not is positive.
How do you see it?
So the full family name is Enterobactericiae, kind of like the way it's spelled. Again, it's one of those really long words, but if you read it nice and slow, Enterobactericiae, right? Like it's spelled. But we abbreviate it to enteric and non-enteric. Okay, so that's often that's the common name for it. So we have our enterics, we have our non-enterics. In your book, so pay attention to this, please, because everyone always asks me for the reagent. In your book, there's like this reagent that you add to something, and then you mix with something, and then what does a positive look like? Anyone remember?
Green?
Nope. But we are looking for color.
Purple.
Looking for a purple color. Okay. I'm going to give you what's called a dry slide. In fact, it's going to have 2 squares on it. Right? There's no reagent. None. Okay, say to yourself right now, there's no oxidase reagent. If you ask me, I get to make fun of you, okay? I'm going to just leave it like that. So all you do is you take your loop, you gently put the bacteria on top of the square. That's it. Don't squeeze too hard. The metal loop can cause false positives. So just gently rub the bacteria on the square, let it sit. The reaction takes 30 seconds to a minute. Look for a positive. Okay, and then again, determine, out of the 2, there's ox A and ox B, which one is the enteric, which one is the non-enteric. Any questions? That's it for the work. It's